Welcome back to the 14th video about my dual engine control lever IP68 project. In the previous video, we machined into the centerpiece here all the features in the bottom here to house the electronic strain relief for a cable and mounting holes. Card here, link in the description. Now, in this video, we want to not completely finish, but make two cutouts into that big chunk of POM so we can actually fit and attach these side pieces. Remember, taking the small Lego model here, these side pieces are detachable. They're obviously not even attached at this point. And this is basically the centerpiece, an inverted T-shape. Enjoy! That's the inverse T-shape I was talking about. And these cutouts are 23 millimeters deep and leaving just here a base plate with a thickness of 6 millimeters at the bottom. Let's mark these lines here on our POM block. So 6 millimeters from the bottom on all four sides. Yeah, I'm searching here in the light. You probably can't see it, but I made some smaller markings beforehand just with the caliper 23 millimeters in. I got a little bit confused with the 6 millimeter lines and I stopped them short on the wrong side. I could have stopped them short here, but now let's do the correct thing with the 23 millimeter lines. I don't intend to mill out that whole area on the milling machine. Instead, I wanna saw out first here a rough block, and I give myself here a 2 millimeter tolerance. So this should, the cut out should stop 8 millimeters from that edge and 21 millimeters from that edge. So these are the 21 millimeter lines. And the 8 millimeter lines. Maybe I should make the 8 millimeter lines also here on the side, just to be safe. And the 23 millimeter lines are maybe also useful here on the top side. The same holds, of course, true for the 21 millimeter lines. And just so that we are all on the same page, so these inner lines here, these are the final cutouts to be milled. And the outer lines, that's what I want to saw away. And from the side, the first saw cut is here, and then we mill down the final 2 millimeters. And the same, of course, holds true from the top. So we saw until that line here and that line, and then we mill down the last 2 millimeters. The first cut is completely doable with my little table saw here, and I hope that that saw blade is working out in POM. So we want 8 millimeters of material left here at the bottom. And the cut should be 21 millimeters deep. So, yeah. The first cut, I show you it later on, went okay, not quite easy. these little plastic chips, they clump up in between. And now we do the second cut, not to the complete depth, that's not possible with that saw, but we're trying to stay away 21 millimeters from the outside, not take more away than 21 millimeters. So the first cut was right on the line. So that worked out as right on the line that it can be for a little table saw. And the start for the second cut looks also quite good, but we will have to finish that manually. So I aligned my POM block here using the existing cut in my manual saw, and now I will slowly and carefully extend the cut here down to that 8 millimeter cut, that is 8 millimeter line. And here's the result. It's not too bad for a manual cut. If you look down in here, you probably can see that I, well, actually did not overshoot, but I deviated here a little bit, half a millimeter or so, which is also, it's a little bit better on that side. But anyway, that's what these 2 millimeter margin are for. We're back in the lathe, and I will first use the planer here to clean up the large face of our cutout. I show you the first cuts. I cannot do the short S here, of course. I have to rely on the long S, and there will be some trimming error, but what can you do? I forgot to film the first rough cut, which is good because I showed something there that you shouldn't do. That is remove any chips while the machine is still running, and now I'm bleeding. I'll come back to you when the situation is resolved. Okay, after you missed out on that, I'm okay. The first rough cut, I will do now a finer cut, just advancing out here after each S half the width, for depth of 0.5 millimeters. And by the way, we have now here, you can see it on the bottom, exactly or about 66 millimeters, so we need to go down 1 millimeter more, and I start that with that 0.5 millimeter cut. Okay, these fine cuts here, just advancing half the width of my planer, they don't cut it because I can actually feel here some marks with my fingernails at the lines where it advanced. Let me think about that. Maybe we make quarter width advances. Oh, we'll see. But for now, I will have to give my finger a little bit more attention. I came up with another plan. I will do the short S curves because I have here 2 millimeter of meat I can take off. So if I mill a little bit here into the back, it really doesn't matter. I will give you a time lapse of the short S's. Now, that's a surface I can live with. And you might have noticed I made one pass here at the very end, at the back on the long side, just to clean up here. I will now off camera do some more of these passes, maybe one or two more. We should be down to 65.2 by now, until I hit the 65 and I finished with that surface at least. That was only one additional pass, 0.1 millimeters, to finish it up and get it down to 65 millimeters. And yeah, everything feels nice. And just as a sanity check, we put our side piece in here. These transitions, while not absolutely perfect, maybe, yeah, there is a little step of a few hundredths of a millimeter or so. It's okay, I guess. It's okay. Now for our little ledge here. I'm using here my end mill with the long flutes. And I'm going down here until I'm touching my finished face manually. Then I lock my depth here, and if we move out now, we might have a tiny weeny scratch here. And then I move my Z-axis until we touch. And then we start to mill. I will take first take off 1 millimeter or so. Unfortunately, I forgot to film it, or I didn't forget it, I just didn't press the button. And the finish here, after cleaning it up a little bit, is very rough. So I will make another path without increasing the depth here on the Y-axis to make this a little bit more smoother. I won't film that, but I will give you the next rough cut. Hopefully remember to press the record button. We are still slightly over 7 millimeters here in thickness, so I make another 1 millimeter deep rough cut, and this time hopefully I will film it. Yeah, we saw this rough pattern here, and it's really rough. Yeah, it's like a washboard. So I'll give you one shot of a cleanup cut without, increasing the depth here on the Y-axis. We're down here to 6.4 millimeters. I will make some smaller cuts now here and clean everything up, mostly off camera because, well, it's not very spectacular. It's just tedious. Okay, I didn't film these cleanup cuts. At the end I was down to 0.05 of a millimeter going in here. And we're now here at the back pretty much at 6 millimeters, and my side piece fits in snugly here. We already saw there's basically no step here, so that's fine. However, here at the side there is a slight step, which is okay because we will round everything off at the end. The big radius sorry, is still missing here on all the pieces. So this will hopefully disappear. Now, while the piece is in the vise, we can as well cut these threads here. And the thing is to cut, because there's a thread from both sides, to cut deep enough for the screw to really grab on and to have enough thread, and not to interfere with the thread from the other side. And I just marked here with a black line on my machine tab here how deep I need to go. I already explained that setup for tapping here in the previous video. Already cut it, but link in the description. I did the second thread off camera, and now one side is basically finished and we can screw on our side piece. And it's almost perfect, almost, because as you remember, I drilled the holes here in the side piece with 6 millimeters, and I mentioned back then that this is a little bit optimistic. And if we have now a look here, I can slide a piece of paper, at least here at one end, between the two pieces. It doesn't work on the other side. There we are really spot on. But anyway, we will have to open up the holes here in the side pieces to, let's say, 6.5 millimeters. That's give us enough wiggle room here for the tolerances. Again, this here, that little slot that opened up here, that's below 1 millimeter. So I can just slit some paper in here, so it's a few hundredths of a millimeter. But anyway, it's no good. We have to open up these holes. I also done that before, but anyway, I first lined up to the hole using the original 6 millimeter drill, so it will go in here without any friction. And then I widen the hole with a 6.5 millimeter drill. I will do the other 4 holes off camera. With the holes in the side part opened up to 6.5 millimeters, I have now here some wiggle room to perfectly align the side part to the center part and then screw it down. I will do most of the cutout on the other side off camera because, you already saw it. I told you I would do the second side mostly off camera, and I already sawed off here that cutout. However, there's a little interesting tidbit on how I clamped now the whole piece back into the vise for the milling operations. I'm using here the side piece screwed in and aligned to to get something to hold on. And please note that my parallels are resting just on that side piece. So in theory, if my side piece and my first cutout are all 2 dimensions and all have right angles here, then I should be able to mill a surface also at a right angle to everything else on the top. We'll see. I come back to you when I'm finished. As you can see, it worked quite well. And things are slowly but surely coming together. That's it for today. Till next time, bye.